Hey everyone, my name is Yograj Sikka. I am student of Center for Global Education at Chitkara University in collaboration with Deakin University, Australia. Today I am demonstrating my task 6.1p, which is project pitch, in which I am pitching my project, which is uh, you can see disaster alert and safety station. Today I am presenting my project, the Disaster Alert and Safety Station. The system detects floods, fires, and earthquakes. It shows live alerts on the map, sends those alerts over the internet using MQTT, and pushes SMS to the responders. I will explain how it works. So you can see I had used Raspberry Pi and Arduino Nano in this to make this project successful. So now move to the next slide. So my problem statement is whenever disaster like floods, fires and earthquake can happen quickly without much warning, early and accurate alerts can save lives and property. Many systems uses a single sensor, give false alarms or they don't tell the responder where exactly the problem is. My idea was to make a system that reduces false alarms by using several sensors, add GPS so alert has a location and send those alert over the internet using MQTT to get them right away. The system also show the affected area on map so that people can see the danger zone. Make several changes in it. If my Raspberry Pi or GUI will not work, then this will happen that my live sensoring will be taken by the Arduino Nano and it will still trigger an alert by the LEDs and the buzzer will turn on. After that, my project goals were the my project goals were detect the flood, fires, and earthquake reliably, to show everything in a GUI that a user can control. 3. Publish a geotagged alert so that other system or people can respond. 4. Send an SMS message to emergency contact. And 5. Keep a local safety fallback so that alarms still sound even if the network or main computer fails. All that together make the system useful for small building, a lab, or similar places, etc. After that, I had made architecture plan for my project. So you can see here my architecture plan. So my plan is to detect it earlier, to make the accurate localization, fast communication using MQTT, and situation awareness, so that developing a user-friendly graphic interface dashboard for live mapping visualization for active danger zone and historic incident data. So these are my some points. After that, let's discuss my architecture. So this is my end-to-end system architecture. So you can see here I split the work between two devices. One is Arduino Nano 33 IoT. This is the sensor node. It reads the sensor temperature, gas, water level using water ultrasonic sensors. After that, it reads the sensors. It also reads the GPS module for coordinates. The Arduino sends its readings over the USB to a Raspberry Pi. The Pi is the main gateway or GUI. The Pi takes the data, show it on the screen, publish it to an MQTT broker on the network, and alert server listen for alerts, send SMS using Twilio, or we can use another apps for this, but Twilio because we had used this before for our another task. The GUI subscribes to an alert topics and draws danger zones on a map using the GPS location. Include in the alert if the Pi or the network fails. The Arduino watches for a heartbeat and trigger a local alarm if needed. The separation keeps the critical sensing safety to local and the user interface and network tasks. So you can see the GUI map plus SMS at the end, Arduino Nano to make the process and collect raw data sensor, MQTT to control the central hub, and Python GUI mapping using the Raspberry Pi. So move to the next slide. So you can see here is a list of the components or hardware components which I am using in this task. There are physical components like Arduino Nano, Pi, MQ sensor, DS182P0, ultrasonic sensor, float switch, IMU, buzzer, etc. For the hardware, I had used Arduino Nano 33 IoT, Raspberry Pi 4, and for gas fire detection, I had used MQ135 sensor. For flood detection, I had used a float switch. For temperature, I had used DS118B20. For waterproof ultrasonic, I had used GSN SR 040. For location, I had used GPS module. For alarms, I had used active buzzer or visualization LED strips. A small opto isolated if needed. All the pieces are common and easy to get. So now let's move to the next slide. So you can see here is the software and the communication stack. The Arduino collects data, sensor values, and the GPS coordinates and send a single line of the data to the Pi, usually once per second. The Pi parse and then convert it to JSON, then publish it into the MQTT like disaster slash site sensor slash node telemetry. The message contains the timestamp, node ID, lat, ion, temperature, gas reading, water distance, float state, and IMU value. When the fusion logic decides there is an alert, the Pi or the server publishes an alert message on disaster alert with GPS and severity. The alert is then shown on the GUI, and the server also send an SMS to the emergency contacts. Using MQTT makes it easy for many systems to subscribe or alert the data, which can further will show on the GUI. And we had used SQLite or PostgreSQL for storing the data and using it for the further historic contents. After that we had used logic. After that we had made the logic. A key part is the fusion logic, that is the decision rules that combine several sensors to avoid false alarms for fire. I use temperature and gas together. If the temperature goes 65 degree above and gas reading rise by the large percentage compared to the baseline, I treat it as the fire action. A flame sensor is immediately confirmation if present. For a flood, I require the float switch to be an ultrasonic distance to be low, or a pressure sensor to read high. For earthquake, I use the IMU on the Nano 33 IoT sampled at around 100 Hz and look for the magnitude spike sustained for the few consecutive samples. I also use a simple smoothing and require 2-3 consecutive samples above the threshold before I raise an action. This will remove the random spike from causing the false alarms. After that, move to the next slide. So you can see MQTT topic structure. So this is my structure. I had used standardized topic structure. The hierarchical structure allow clients to subscribe broadly to a data, narrowly to specific sites or the data, telemetry versus alerts. So you can see here I had made the critical JSON payload, which can trigger the SMS whenever it go high or the temperature gets above it. So you can see here, this is my MQTT project overview. So that after that I had made real-time GUI functionality or dashboard, which can use for the GUI mapping. Or the another thing, the GUI is the control center. On the left there are threshold controls where the user can change the number in real time so that it will not make my code the hard coded. In the center, I show the live charts for the temperature, gas, the water level, and overtime. On the right I show a map with the markers for each node. When an alert occurs, the system draws a circle around the GPS to indicate the danger zone. The user can click at any marker to view the sensor history for that node, can press to turn the pump on or off manually. The GUI also keep a log of all alerts and lets your data export. After that, move to the next slide. The operation interface or real-time monitoring. I can made the real-time monitoring by node location mapping. The graphical user interface displays all the node. After that we had used severity markers, which I had mentioned earlier. The markers are color coded to reflect the severity area and ensured rapid prioritization of critical incident by after that, manual actuator controls like buzzer, relay module, and directly from the dashboard. After that, I had made automated and prioritized SMS notification system. So I can show you about, I can tell you about flood and fire also. In flood, first the flood test. On the simulator, I toggle the switch to on. You see the GUI immediately showing a warning. Next, I simulate the ultrasonic sensor dropping to 18 centimeter. The system confirms that flood and accelerate to action. The Pi sends the commands, and the LED and buzzer will turn on. The system also publish an alert to MQTT, and the server sends an SMS to emergency contact. You can see the SMS appear on my phone. The map shows a red circle around that. After that, for the fire, I simulate the rapid temperature rise and a large gas reading. The fusion logic sees temperature above 65 degree, the gas reading above the action level, so it will detect raise and fire action. The GUI shows a red alert and danger circle. The local buzzer sounds and the pi publish the alert message to MQTT. These are some assumptions readings, because I can change the threshold by using the GUI which I made which I made using Raspberry Pi. So my code will not be hard coded. I can change the Raspberry Pi or the threshold frequency so that it can be compatible for any area, for any country, for any surroundings. So it will make it compatible for everything. After that, I use for the earthquake plus fallback. Finally, the earthquake test, I simulate an IMU spike over the consecutive samples. The system detects it and raises a quake alert. The GUI shows and it publishes that alert. Now I demonstrate my fallback. I stop the Pi software so it no longer send heartbeats. The Arduino times out the heartbeat and switches to the fallback mode. It checks local critical threshold and seeing the float still on a large IMU spike, it activates the buzzer and local LED. This ensures the alarm system work even if Pi or network fails there. After that, I had used something different. So you can see the emergency response workflow, the workflow like sensor activation, and then data will be transmitted over that event classification. So that data will be checked and predefined thresholds and classify the event severity, critical action or warning. After that, GUI and accurator will trigger and send the SMS over it. So you can see the testing part. Now testing and evaluation protocols. So now this is the important part. For the gas sensor, I let it warm up for 24 to 48 hours and logged into baseline values. I calculated the mean and standard deviation and set warning and action threshold related to the baseline. For the ultrasonic sensor, I measured several known distance and created a sample mapping table. For the IMU, I did a set of tap tests to find a threshold that picks up the significant shakes but ignore the normal bumps. I will include these logs in the final report. After that, I had given the limitations or limitation and safety notes. There are limitation. MQ sensor can drift over time, so they need recalibration and occasionally replacement. GPS accurately depends on satellite visibility. I use HDOP to show confidence and adjust the values radius. If the HDOP is poor, when the switching mains loads pump, I recommend a qualified person do the wiring. Yeah, I can do the future improvement also. Future work also includes adding a dashboard showing multiple nodes on a campus using machine learning for anomaly detection for the further reduce false positive integration evaluation and another things. After that, I had used in the conclusion, I want to say the disaster alert and safety station is a practical protocol that fuses the multiple sensor, provides the location aware alerts, public event over the MQTT, shows danger zone on a map and send the notifications. It also includes a safe fallback so that alarm continue if the network fails. I will submit the code wiring in my my project report, which will be I am further reporting in which will be I am submitting later on. So thank you, have a nice day.